Right, so this is our last lesson on lines, but it actually seems more like our first lesson on trigonometry. So we're going to talk about radians, and we're going to talk about some special angles. Radians. Okay, right, let me draw part of a circle. Let me draw a sector of a circle. There we go. And let's say that this angle is, I don't know, theta. Everyone's favourite angle is called theta. Let's say I want to know what is, please, the length of this arc. Now, maybe pause for a second and just think about it. So, the length of this arc, I could work out easily the circumference of the circle, right? So, the circumference of the circle is 2 pi r, where r is the radius of the circle. That's obviously going to be r as well, the radius of the circle. And this is a fact that we've learnt since sort of many years ago. Now, interestingly, if I want to work out this arc, I could think about this as part of a circle or a fraction of a circle. So what fraction of the circle have I got? I have got theta out of 360 degrees. That's the fraction that I've got here. And I've got that fraction of 2 pi r. And this is going to give me the length of this arc here. So let's put that in L. That is the length of the arc. Right, here's the fun bit. Basically, right, some clever clog said, well, why are there 360 degrees in a circle anyway? That's such a random arbitrary number. Where did this even come from? Why don't we change our system of measurements, sod this degrees nonsense. Let's have a thing, I don't know, call it radians. And let's say that there's 2 pi radians in a circle, right? So what we're doing is we used to have 360 degrees in a circle. Solve that. Instead of 360 degrees in a circle, let's have a new thing. Let's call them radians. Why not? And let's say that there's 2 pi of them in a circle. Why? Because everyone loves pies. But more importantly, if this is in degrees, let's convert that to what happens if we do it in radians. Well, in radians, I still know the circumference of a circle. It's still 2 pi r, where r is the radius, 2 pi times r. And then the fraction of the circle I've got is theta radians out of 2 pi radians. And just have a wee look here. This cancels out, right? It's like having, I don't know, 6/3 is the same as 2. It's cancelling out. Divide by 3 top and bottom. Or 2 over 1 if you like. So this cancels out, and that's the same thing as just saying theta r. So the length of the arc, when I'm talking in radians, is just the angle times the radius. And that's pretty and nice, and that's ugly and messy. So this radians thing kind of caught on. Okay? We just don't do it in like lower school because pies are confusing for like small people. Okay, so basically we've got a system where instead of 360 degrees, we have 2 pi radians. You can then work out some other stuff, right? So what if I have 180 degrees? What's 180 degrees going to be in radians? Pause and guess. Well, hopefully you said pi, because that's half of that, and this is then halving to get to pi. 90 degrees in degrees is going to be what we call pi by 2 radians, or half of pi. Some other important angles. How about 0 degrees? That would be 0 radians. That's nice and easy. How about 30 degrees? How and why do I want to do 30? Well, I just, have a look. 30 is going to be a third of that. So I could call it pi divided by 6 or pi by 6. 60 is going to be that doubled. So it could be 2 pi by 6, but that's a little bit silly when I could just write pi by 3. So these are really the key special angles that we are going to be interested in the second half, special angles. And this is a conversion that says, how do I get from degrees to radians? But the easiest thing probably to remember is probably just this one, right? Pi is worth 180, and then convert everything else to make life work. Okay, special angles. Actually, no, you know what? Let's do one more example first. let's pick a random number of degrees. Let's pick something like 72 degrees. Well, how am I going to convert it? What I'm going to do is I've got 72 out of 180, and 180 was worth pi. So one way of converting, because 180 is worth pi, how much of 180 have I got? And then that's how many pi's I have. So you could do that, you can simplify that fraction down. It's 36 out of 90 pi, which is divide both by 3. That's going to be 12/30ths of pi. Divide them both by 2, and that's 6 over 15 pi. Divide them both by 3, and that's 2/5 pi. There we go. Anyway, 72 degrees is 2/5 pi precisely in radians. And if you're that kind of person that loves just having a number, you can obviously do that if you want. You can do 2 times, where's pi on this? There we go. 2 times pi divided by 5. 2/5 pi, see, it's better. And that's 1.26 radians. Radians is this little C symbol in the sky. Okay, it's kind of like a bit of a degrees. We can check it right actually. Let's just check. 72 divided by 180 times by pi. Oh yeah, good. Yeah, I got it right. Excellent. So, moving on. We can convert between degrees and radians. Radians is just a new alternative to degrees because, hey, degrees is just too easy, right? Okay, special angles. Special angles come from special triangles. Let me draw a really cool triangle that we love. This is a very special triangle. This is an equilateral triangle. So it's got 60 degrees in every corner, and their sides are all equally long. So, I mean, for example, this side is 2, this side is 2, this side is 2, they're all 2. What I'm going to do now is get this special triangle, and I'm going to cut it in half. This is its perpendicular bisector of this side. It's also the altitude of this triangle, and it's also the median of this triangle because they're symmetric, so that's interesting. But anyway, that's length 1, that's length 1, that's 90 degrees. That bit up there, that's obviously 30 degrees, and that's 30 degrees because I've cut it in half. 30 and 30. Great. Because that's a right angle, I can do some Pythagoras here, which is kind of cool and useful. So that's 1, that's 2. I know that the short squared plus the short squared equals the long squared. So 1 squared plus, I'm going to find this one out, right, the height. 1 squared plus something squared, question mark squared, is going to equal 2 squared. So 1 plus something squared equals 4. So something squared equals 3. So my question mark is going to be root 3. This height here is going to be root 3. Now, I'm going to go ahead and assume that you know this thing. So SOH, CAH, TOA, and how to use it. So that's something that we're going to assume, and there's a really cool way of remembering this, which I've included in our lesson slides. So, okay, right. If we know how to use this, we could look at, say, this angle here, this 60. If I look at this 60, then I can go ahead and say sine 60. Well, sine is opposite over hypotenuse, for this 60, which is root 3 over 2. Sine 60 equals root 3 over 2. I can do cos 60. Cos is adjacent over hypotenuse, which for that angle there, the adjacent is 1, the hypotenuse is 2. Cos 60 is a half. I can do tan 60. Tan is opposite over adjacent. So opposite over adjacent for this angle here is root 3 over 1, which is root 3. So here I've worked out for 60 degrees what all of the actual precise angles are, precise trigonometric ratios. Sine 60 is root 3 over 2. And these are things that you're going to be expected to be able to know and recall throughout the course, actually. So these are just basically, today's full of remembering a lot of things. I'm sorry about that. But you can always draw the triangle and derive it if you want to. I can do the same thing. I can do the same thing for 30 degrees. Okay, so let's do that here. Let's work out sine 30, cos 30, and tan 30. So looking at my triangle, that's 30 degrees there. So sine 30 is opposite over hypotenuse is 1 over 2. Sine 30 is a half. Cos 30 is adjacent over hypotenuse, root 3 over 2. Cos 30 is root 3 over 2. And tan 30 is going to be opposite over adjacent. So tan 30 is 1 over root 3. There we go. You can compare and see basically all that happened is the sine and the cos kind of swapped over, and the tan has done some flipping thing as well. Great. So these are some of the special angles we're supposed to know, the 30s and the 60s. The last one that we're going to want to know about is going to be the 45s. I haven't got any 45s here, but 45 is a nice triangle too, right? 45 is gradient 1 when you think about what we learned just before. Because if I go across 1 and up 1, then what is that? That's 45 degrees. That's half of 90 degrees. Is going across 1 and up 1. 1 squared plus 1 squared is 2. So that's going to be root 2. So if I have a triangle that's 45 degrees, I've got this relationship here. So what I can work out is I can say, okay, sine 45 is opposite over hypotenuse, so 1 over root 2. Cos 45 is adjacent over hypotenuse, so 1 over root 2, the same. And tan 45 is going to be opposite over adjacent, which is going to be 1 divided by 1, which is going to be 1. So tan 45 opposite over adjacent is going to be 1. Great. So to summarise, all of these special angles, which I'm afraid we do need to memorise, or at least know how to derive, we've got 30, 60, 0 matters, 90, and that'll kind of do for now. And we're going to know what sine of it is, what cos, and what tan are. So let's just fill in this grid. It's a nice, easy way for you to see all the things. And just because we're not happy enough with just the degrees, we can also do, so that's degrees, we can also do radians, rad. So 0 degrees is 0 radians. 30 degrees, we worked it out, well let's start over here, 90 degrees is half of a pi, right? Pi over 2. 60 degrees, we worked that out over here in this list as pi by 3, pi by 6. So we need to be able to recollect and know that sine 0 is 0, that sine pi by 6 in radians is going to be a half, same as sine 30 in degrees, which we worked out here. We need to know that sine 60 is going to be root 3 over 2, sine 90 is going to be 1, cos goes the other way, so cos 90 is going to be 0, this is going to be then a half root 3 over 2, and 1. Tan, we've kind of worked those ones out here, so let's have a look. Tan of 0 is 0, tan of 90 is a disaster. Remember the graph, it kind of pops off the top and back on, who knows what it's doing. Tan of 30 is 1 over root 3, and tan of 60, we worked out here, is root 3. Oh, and I missed 45. 45 is half of 90, so it's pi by 4. Sine and cos of 45 are both the same. 1 over root 2, 1 over root 2. Tan of 45 is going to be 1. So these here are the facts that you need to know by heart, or at least be able to work out very, very quickly. Of course, you could work out tan by doing sine divided by cos, so I guess you could just remember these two and then do tan is sine over cos. That's one way of doing it. Hope that helps.